All right, hello everybody. Mr. LaHaye here. Not going to be in today, so rather than taking a day and doing absolutely nothing with it, I am going to introduce you to our next chapter, our next unit here, using the iPad. So hopefully I can make sense of this for you enough so that you can try it, get acquainted with it, and get on with it so we can do it tomorrow. Notes real quick before I have your sub pass out the packet that you're going to have here for organic compounds that have some of the instructions on it. Just a couple quick vocab items here. First of all, we're dealing with organic compounds and covalent compounds in this next chapter. It's going to be quick. I'm planning on having a test next Monday or Tuesday, so a week from today or the day after. And I'll let you know as we move through this week. But basically, all this unit is a quick rundown on properties and naming of two other types of compounds other than organic compounds. So the first type, I'm sorry, not other than ionic or organic compounds, other than ionic compounds. So we've already talked a little bit about covalent compounds. Now I'm going to introduce you to what are known as organic compounds. And please understand this is just scratching the surface of what an organic compound is. There's entire courses, years of study in college if you go into the medical field or chemistry in any way that have to do with organic chemistry. Perhaps you've heard about them. But this is just the general idea, just a very quick intro to organic chemistry. Something is considered to be organic if it's a hydrocarbon. The simplest class of organic compounds that contain only carbon and hydrogen. So basically hydrocarbons have carbons and hydrogen. Organic chemistry in general is the chemistry of carbon because organic beings and compounds have to involve carbon. We are organic as human beings and we are composed of carbon. So aliphatic compounds are carbons that are found in a chain-like nature, but they don't form rings. So we're not going to deal with rings of carbons. Those are known as aromatic, and we don't have to worry about that. So we're not going to get into benzene rings, as they're called, just chains of carbons. The only aliphatic compounds we're going to deal with are what are known as alkanes, which are aliphatic compounds where carbons are joined by single bonds. You haven't learned about anything other, well, we really haven't gone into bonding yet, and we will soon, but single bonds, there are things known as double bonds and triple bonds, but single bonds are the simplest type of bond, and that's all an alkane is. So that's my introduction to what organic chemistry is. Those should go in your notes. And now you can pause this so you get the packet handed out to you. So I can go through exactly what you're going to be doing with organic compounds the next 2 days. Okay, so you should have a packet now that looks like this. And you see alkanes on the top, hydrocarbons, which only have carbon and carbon single bonds. And basically what you're going to be doing here is you're going to be following this procedure that's highlighted here. You're going to be following this procedure for naming organic compounds. Okay, and again, mostly alkanes. So it's pretty straightforward. You pick the longest continuous carbon chain, straight or branched. And I'll show you what I mean by that. But just as many carbons in a row, you count them. And then based on how many you have, you number the chain. And then based on the number you have, you're going to call it a methane, ethane, propane, butane, pentane, hexane, heptane, and so on. And you've probably heard some of these words because obviously gasoline and other ignitables are organic compounds as well. So you're going to base your chain name off how many carbons there are. Then you're going to number the chain, so the substituted groups, and substituted groups are groups that come off the main chain. You can have what are known as alkyl groups, which are other chains of carbon, or you have other substituted groups, which are just other elements. Okay, so you want to have the first substituted group to have the lowest number, lowest possible number. So if groups have the same number, then you'll use alphabetical order for the name of the group, and this will make more sense as I show you a couple examples. Then you write the numbers and names of the substituted groups, and then name the parent chain. Okay, and one quick thing. You may need to watch this video more than once I go through some of the naming. If you have more than one of a certain substituted group, then you use a prefix, such as di if you have 2, tri if you have 3, or tetra if you have 4. And I won't give you anything greater than 4. So those are the rules for you to reflect or to look back on as I go through this packet. Okay, so I think we're ready to start now the examples. If you look at number 1 here, we're going to name the following compounds. The first thing to be done is to count the longest chain of carbons. The longest chain of carbons is, well, we could just count them out. Let me just grab my highlighter here. I'll start from the left side. Could go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. Or 1, 2, 3, 4. Obviously, the longest chain was the one that had 6. So, based on that, this is my longest chain that just goes across. Again, it can be straight, or if this were longer, it could be bent. Okay? Now, at that point right there, because I have 6 carbons in a row, if you look back on your sheet, 6 in a row is known as a hexane. So I'm going to write hexane in here because we know that this is a hexane. Now, if there was nothing substituted to it, it would just be hexane, if it was just carbons and hydrogens. However, you notice there's an iodine right here, and there was this CH3 group that is right here. So those are what are known as substituted groups, and we need to name them. Now, as it said on the other side, I can either start from this side, I can start from this carbon, but I wouldn't hit my first substituted group until 1, 2, 3 carbons in on the parent chain. However, if I start on this side, I have a substituted group on the very first carbon, which means I'm going to start numbering from this carbon. And I'm going to number them. This is number 1, 2, 3, 4, 5, 6. I have 6 carbons in the chain. Now, you don't name hydrogens because they're just expected to be there on a hydrocarbon. But an iodine, if you look on the other side, we call it iodo. So this would be 1-iodo, 1-iodo, comma, and then I come over here, and on the 4th parent carbon, I have a CH3 group. Well, if you look there, that's a methyl over on the other side. So I'm going to write it up here because it's getting sloppy. This would be 1-iodo, comma, 4-methyl hexane. That is the name for this first example. Now, for the second one, you can clearly see the longest carbon chains right down Broadway, right down the middle. It's 5 carbons. So looking back on the other side, that is what we call pentane. I'm going to go ahead and erase this now. So if we have 5 carbons in a row, longest chain, then it's a pentane, and we would write pentane. But it's not just carbons and hydrogens. We have substituted groups here, here, and here. So we need to name them. Again, you can start on this side, but you wouldn't hit your first substituted group until the 3rd carbon in. But if you start on this side, you have your first substituted groups on the first one. So you start naming from that side, start numbering 1, 2, 3, 4, 5. So that means our name would be 1, 1, because there's 2 bromines on that first one, dash bromo, oops, almost made a mistake. If there's 2, you have to name it dibromo. And again, that was mentioned on the other side. 1, dibromo. Not going to have room here. And then 3 chloro. Pentane. So 1, dibromo, 3 chloro, pentane. That is number 2. On to number 3. Once again, we want to find our longest chain. Now, if you're new to this, you might think the longest chain, 1, 2, 3, 4. However, it can be bent as well, and if you go that way, you'll go 1, 2, 3, 4, 5. So your longest chain here is of 5 carbons. that bend down, which means that this is a substituted group. It's not on the main chain of 5 carbons, which bends down here. So that is your only substituted group. So, being that the main chain has 5, again, this is a pentane, as with number 2. That is a pentane. And whether you start from this side or this side, you're not going to hit that group until the 3rd carbon. 1, 2, 3, or 1, 2, 3. So it doesn't matter which side you number from, and that's your only substituted group. So this would be 3-methyl, because that CH3 group is a methyl group, 3-methyl pentane. 3-methyl pentane. The 4th one, once again, my longest carbon group is, nothing's bent here, so it's just 4 carbons. I accidentally circled a hydrogen there. So that's a butane. 4 carbons is a butane. And I have a group on the that carbon, the fluoro group, and a bromo group. Now, another thing I mentioned on the other side, if I start from numbering on this side, I get to my first substitute group on the 2nd carbon. If I start from the right side, we get to our first substituted group on the 2nd carbon, so it's a tie, so to speak. However, if in the event of a tie, you go with the alphabetical group. Okay, so we would start here and label 1, 2, 3, 4, meaning that this would be a 2-bromo, 3-fluoro, butane. And that is naming organic compounds. Try your best. If you're struggling, try your best, and we'll go over it tomorrow. But I'm not done yet. The last thing we need to do is actually given the names, draw the structures. Okay, well, you want to kind of work backwards when you're drawing the structures. And what I mean by that is, look at your carbon chain. This is a heptane, which means we need 7 carbons in a row. And I'm going to use black so I can do it down here. You might as well keep it simple and make it just a long chain, straight across, 7 carbons. Now I like going left to right, so I'm just going to follow directions. On the 2nd carbon, I have a methyl group. So, coming off this 2nd carbon, I'm going to do a CH3, a methyl group. On the 3rd and 5th carbon, it says dibromo. Well, remember, the di is just there because there's 2 of them, and it tells you the relative locations, 3 and 5. So coming off the 3rd, I'm going to put a Br group. It really doesn't matter if it goes up or down off that carbon. I put it down because I don't want it to get in the way of my methyl group up there. And then coming off the 5th, again, 1, 2, 3, 4, 5. Coming off the 5th carbon, you will have another bromo group. So that's your chain. You got it all drawn there. You have your substituted groups. And now you have to put a hydrogen in every other place. So every carbon on the main chain should have 4 things bonded to it. Where it doesn't, you need to add a hydrogen. And that's what you do to fill out, the rest of the picture. So that's an example of number 1. Next I'll do number 2. Number 2 you can see is an octane. So I need 8 carbons in a row for an octane. 8. Now, I like starting with the left. You see it goes 1, 3, 3 tribromo. That means I have 3 bromo groups, and they are on the 1st, the 3rd, and the 3rd carbon. So there's my 1, 3, 3 tribromo. 4-ethyl. So coming off the 4th carbon, which again would be right here, because I started from this side, is an ethyl group. Now you may need to go back to the other side of the paper and look at your ethyl group. It's a CH2CH3. Basically that just means it has a carbon, and then coming from the 1st carbon is 2 hydrogens, CH2, and then CH3 on the 3rd one. And that's your ethyl group right there. Everything else has hydrogen coming off those main chain carbons. They need to be bonded to 4 things, and if they don't have a substituted group, then they must be hydrogens. And there it is. That's 1,3,3-tribromo 4-ethyl octane. Now, what to do with yourself for the rest of this hour? What I would like you to do quietly and by yourself is the following things. Number 1, I would like you to try your best to complete the organic compounds sheet that you will be given. Both sides. So organic compounds 1 and 2. Number 2, I would like you to take Cornell notes using a textbook. Very short this time around, on pages 192 to 193 and 197 to 198. And then finally, if you have more time on your hands, pick up daily data number 4. It is blue, should be on the front table, and it says covalent compounds. Covalent compounds. There is graphing on there. Make sure you title your graph. I'll be back tomorrow, make sense of anything that doesn't make sense, and we will start to move forward with this chapter. Hope you all have a wonderful day. Thanks for watching.